Hey everyone, so this is my Physics 2 Lab 1 on charged tapes. So the purpose of this lab was to observe the interactions between objects of different charges and then to calculate the excess charge on one piece of tape. So some models and fundamental physical principles that we used, it was Coulomb's law and then Newton's second law, which is force equals mass times acceleration, and then Newton's third law, which is every force has an equal and opposite force. And so the main lab result was the tape was positively charged. The excess electrons or excess charge that we found was 8.75 times 10 to the 10th. And then the charge on the tape was 1.48 times 10 to the negative 8th coulombs. So some physical or physics principles that we used was the electric force, which is charge times electric field. And then the formula for electric field, which uses charge, the K constant, and then distance. And then we just had to rearrange those equations to find the charge for tape B. So the systems and surroundings in this experiment, the system was the two pieces of tape, and then the surroundings was just everything else. And then initial conditions, the length of the U-tape was 0.2 meters, the mass of the U-tape was 0.0002 kilograms, and then the position of U-tape A was just at like the zero origin. And going back, we used Newton's second law to calculate the gravitational force. I just want to throw that in there really quickly. So the experiment, some assumptions we made were we ignored air resistance, and then we treated tape as a point charge. And then we assumed each U-tape had the same amount of charge evenly distributed along the length of the tape. So when testing the charge of the tapes, when brought close together, U-tape A and B showed repulsion, so that meant they had the same charge. And then I rubbed a pin through my hair, giving the pin a negative charge. And when the tape and the pin were brought together, they were attracted, meaning the tape had a positive charge. So I floated tape B above tape A, since they were showed repulsion, and the distance between the two pieces of tape was 0.03 meters. So that was the distance that we used in further calculations. So here are all my calculations. The magnitude of the gravitational force for tape B, which was the one that was floated above, was 1.96 times 10 to the negative 30 newtons. And because it was there and we disregarded air resistance, and it was magnitude of gravitational force and electric force, the two were opposed, so they had to be equal and opposite, like Newton's third law states. And like my third bullet point there shows. So the charge of one piece of tape, I rearranged the electric force formula and calculated the charge, which came out to be 1.4 times 10 to the negative 8 coulombs. And then I divided that by the charge of one electron to determine the number of excess electrons on the tape. And then to calculate the number of atoms on a sticky surface, I calculated the area of the tape using the length and the width, and then divided it by the area of an atom. And then finally, ratio of electrons to atoms, I just divided the number of electrons by the number of atoms that I calculated. So my computational model, basically it's all the calculations I did previously for the experiment in code, and then the image shows the red force, which is gravitational force, and then the yellow arrow is electric force. So some similarities and differences between the experiment and computational model. There were similar U-tape charges and number of excess electrons, just off by a few decimal places, which could just be due to experimental error and possible source of error touching the charged tape too much, which could make it more neutral and not as attractive or repulsive to other objects that it's brought in contact with. And then I could have just coded something incorrectly. If the electrons had a positive charge and protons had a negative charge, what would happen? Nothing would change because every object observed would have just the opposite charge of what it currently has. So they'd still be attracted or repulsed by the same thing. So nothing would change besides just the physical charge that they actually have. And then why it's important to handle the charged tapes with as little as possible. When you touch the positively charged tape with your neutral hands, the tape becomes more neutral as it tries to reach an equilibrium with your hand. So it just throws off the rest of the data. So in conclusion, opposite charges attract, like charges repel. Objects can become more charged positively or negatively, or more neutral depending on their interactions with other objects. Thanks for listening.